Okay, so this is question 5-8 of the 2016 mock. You guys sat? Let's see. Okay, so I've already actually done this. I wonder if I can delete all my answers. Okay, let's do this. Okay, so here's question 5. Basically, it's a nice little trig question. We have to find height of the bridge from the bottom, okay? So we can make this into a right angle triangle. I just pull that over and then bring one down from the top. Okay, and what we're after is, let's call it x, okay? Here's for x. We've got a right angle triangle here. This is the hypotenuse. This side is opposite the angle, given the adjacent. So we know the opposite and adjacent. So we are going to use tan. So tan 22 is equal to opposite, which is x over 57.25. So x is equal to 57.25 times tan 22, which you can put straight in the calculator. 57. Okay, so that gives us the height of the triangle. It's 23.13, and then we need to add on the height of 1.2. So we get a height of E above the height is equal to 24.33 meters, or the nearest centimeter. Okay, so here we are, the nearest centimeter. Nice trig question. Alright, going on to question 6. Proposed airport development. Okay, so we've got a relationship between the number of jobs in an airport, which is y, against passengers, which is x, given the line of best fit. And we have to estimate from this the number of passengers passing through the airport. So when the number of jobs was 65,000. 52818, and that is x. So we're trying to find out what x is. I can just go straight to the calculator, put in 65,000. I'm going to add on 5281. 52818. And then divide by 2100. So x is equal to 56.1 million. So our answer is 56 million. And that is to the nearest million. And let's actually call this a number of passengers. Okay, now we've got the actual number, and is is this, calculate the percentage error. So these two lines mean absolute value, which is the distance from 0. So if I put in absolute part, so 56, 1, 2, 3, 4, 5, 6, subtract 6, 8, 4, 8, 8, 0, 0, divided by 6, 8, 4, 8, 8, 0, 0. And this whole thing again multiplied by 100. And again, put it straight in the calculator. Enter, divide 6, 8, 4. No, it doesn't look quite right. I have missed the 0 off. There we go. Okay, and then multiply by 100. And because this is an absolute value, all we have to do is ignore that negative sign. And we get 18.2%. Okay, we're not interested in whether it's positive or negative, we just want a positive value. Okay, according to economic predictions, 1 million more passengers pass through the airport would generate approximately 2,000 more jobs. So the gradient here of this, the gradient of this line is 2,110. Which is close to 2,000, which is fair enough. The gradient or slope is increasing at a constant rate. Right, now we've got another formula. Same type of thing except for the length of a runway. The longest runway is 1.5. So again, we're just working out what x is, 0.7 times by 3 to the power of, okay, that's not correct. So x is equal to 0.7 times 3 to the power of 1.5. Close brackets. So the number of passengers is equal to 3.6, which is rounded to the nearest is 4 million. Okay, 3.6 would round up to 4 million. Okay, this last part, we have to talk about the pros and cons of building an airport. So copy and paste this in. Identify the relevant mathematical information. So 2 marks for this. We could talk about length of runway, number of jobs, size of aircraft. You only need 2 things or more to get the 2 marks. Safety, considering the measured distance from places. Okay, 2 things for that. Appropriate calculations. So we're going to go back to our formula. So we're going to use our runway length, this one. And we need to actually work out the length of the runway, so if I click, it is, let's say, 3.5. One point five. 1.5, 3.5, 3.5, 3.4, yes. Do it accurately. Right, 7 times 3, power of 3.48. So x is equal to 32.02. So the number of passengers is equal to 32 million. We could also use the information that they gave, that there's 18,000 jobs. And I will use the other formula that they gave us. So I'm using the information that they've given us. And they say there's 18,000. So x is equal to 18, 1, 2, 3, plus the 5 to 8, 1, 8, divided by 2, 1, 1, 0, 33.56. So in this instance, the number of passengers is equal to 34 million. So it's slightly different. Okay, consider the accuracy of your predictions. Okay, and it's important that you use the information that they give you, okay, and work back and find the number of passengers. Okay, consider the accuracy of your predictions. Okay, well, we can talk about we are dealing with measurements that are not 100% precise, which may lead to discrepancies. We are rounding to the nearest million. And notice an error. Let's be an absolute error of 2 million. Okay, so it's again 2 things you want. Comment on the sustainability. So for this, you have to say whether it is sustainable or not sustainable. You can't. You have to state one or the other. It is sustainable because it is not sustainable because it has to be one or the other. Okay, with reasons. So you can talk about safety. It is in a safe area and a safe distance away from local houses. We could talk about the length of runway. There is around 5 kilometers, and there is room for expansion. Room for expansion of the total airport. Land to add more runways. And facilities and services. So we can talk about the availability of transport links, whether there is or not, and whether it would make it more sustainable. Okay, so it works for the last part as well. Okay, so going on, that's question 6. Looking now at question 7. Okay, we've got the determine the exact area of the circle. So we've got the formulas up here. Pi r squared. Area is equal to pi r squared pi times, and the radius is 65 squared. We can put that in, and that gives us 4.225. And then don't forget your pi. It has to be in terms of pi. The next part looks not very nice, but we're given all the information. We've got the power, efficient power, and PA, which is this thing. A is the area, U is the wind speed of 30, and we're dealing in watts, but it has to be kilowatts. So PE is equal to 0.45 times 0.6 times A, which is the area, times 30 cubed. So just putting this all in. And we get this, and that is in watts. So I need to divide it by 1,000. Give me 9, 6, 7, 6, 2. Okay. We're going to do it. Kilowatts. Alright. So that's just substituting numbers into a formula. Okay, wind turbines need to be placed quite far apart. This is the turning zone. 5 times the diameter of the rotors. Show that the radius of the circular zone needed for one turbine is 325. Alright, so if the rotor diameter is 130, I've got 5 of them, so that gives me 650. And then the radius is half the diameter. There we go, 325. Alright, the last part. Design a wind farm using these 130 meter turbines Okay, so this is our turning zone. So if we put one of these here, we could have a wind turbine here and here. And we can't have anything in the middle. So let's copy and paste so we don't miss any points. Okay, so identify the strategy. So try an arrangement of, let's see how many of these we can fit in. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Arrangement of 6 by 2, which allows us to have, so an arrangement like this, we could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, determine the maximum number. Now, if you actually put 14, you get the 2 marks. Okay, but just out of interest, there's a better way to do this, which is to arrange it like this. Which means we can fit another row in. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Can I fit another one in here? Yes. So in this arrangement, 1, 2, 3, 4, 5, 6, 6, and 5, and 6. So that's 3 rows. We could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And if you put 14, you would still get the 2 marks. Okay. So estimate the maximum efficient power output. So if one output is this, power output is that. Then we times that by, I can put 20. So the maximum power, 935, 236. And I'll round it up kilowatts. So let's just put a number, using the number from the last part. Consider the sustainability. Okay. Let's talk about the diameter of the rotor. For better use of the land, we may need turbines with a different diameter. And we can also remove with the average wind speed. And since turbines do not operate above this 30 meters per second, this means they will not operate at the time, which is a bit daft. Justify the degree of accuracy. So these are things like wind speed is not guaranteed. So the TE is not reliable. And my answer from 7A was rounded. So it will reflect in the degree of accuracy. Okay, again, you're only looking for like 2 things. Alright, a nice little problem. Okay, last one. So this one we're looking at bridges. We've got coordinates. We have to write in the relationship between the coordinates of C and coordinates of A. We can see that the x coordinates are all negative compared to the C ones. So the y coordinates are the same for both A and C. The x coordinates are the negative values for A compared to C. Okay, we're talking about x, so you have to be specific about which ones we're talking about. Write down the relationship between xq and xc. So these are half. X Q is half of x c. Okay, I need to predict what this is going to be. 2, 3, 4, 5. It's going to stay the same. 6, 7. Okay, just a nice simple pattern. Pattern of the general rule for C in terms of n. So it's going up. It's an arithmetic sequence 4, 6, 8, 10. It's going up by 2 each time. It's going to be 2n. Plus 2. I should really write x c is equal to this one, xq is equal to it's going up by 1 each time, and this one. Again, that is just another arithmetic sequence. Verify the rule for xq. Okay, so to verify we have to use n is greater than 4. Okay, you can use one of the ones, but you only get 1 mark to get all the marks. Use n is greater than 4. So when n is 4, using our formula, x q is equal to 4 plus 1, which is equal to 5, which is also the same as in the table. And you have to put the justification, okay? You can see it's the same up here because we have filled it in. Okay, and you have to state this. You have to acknowledge that the two values are equal. Right, justify why the y coordinates of the different midpoints take the value 3. Okay, because it's the average of 0 and 6, which is equal to 3. Or you could put it's in the middle of the height, which is 6 over 2, which is 3. Okay, so this one, we've got our animation. Use the animation, we need to write, show that the gradient from A1 to Q1 is 3 over 6. So gradient is equal to rise over run. So we've got a rise here of, you can see, yep, 3 take away 0. Divided by the run, which is 2 take away negative 4, which is equal to 3 over 6, which is 1 over 2. Take away that x1 take away x2 over y2, y1 take away y2. Okay, and the last one. This is quite big one. Right, so describe any patterns you see for the gradient of AQ and for the coordinates of P. Okay, so basically if you find this table, you will be picking up those marks. Okay, you'll be making predictions actually. So we can see 4, 6, 8, 10, 12, 0, 14, 0, negative 4, negative 6, and this is just the negative values. Two, 3, 4, 5, 6, and it's 3. 7, and it's 3. Okay, the midpoint we can see it is, P is exactly the same the whole way through. Okay, and the gradient, we're doing 3 take away 0 over 2 take away negative 4. 3 take away 0 is 3. 3 take away negative 6 is 3 out, 6, which is 9. 3 take away 8, sorry, 3 take away 0, 4 take away negative 8. And the same with these ones. Okay, so if you follow the table, you're getting yourself 4 marks, which is quite nice. Now we're looking for, describe any patterns you see for the gradient AQ. So these are gradients. Okay, so we can say numerator is always 3. The denominator forms a 6, 9, 12, 15 arithmetic sequence. so on. And for the coordinates of P, coordinates of P are all the same. Same for each value of n. Find a general rule for the gradient of AQ in terms of n. Okay, so gradient is equal to rise over run. We know it has to be 3 over something. Okay, but what is going to go on the bottom? Okay, that is going to be our... Okay, so the top number is always 3. The bottom number is going to be whatever this sequence is, okay, because that's our denominator. So 6, 9, 12, 15, 18. Has a common difference of 3. So the sequence begins with 3n. So if I try it out, 3 ones are 3, it should be 6, 3 twos are 6, but it should be 9. So I have to add on 3. So the general rule for the denominator is 3n plus 3. So the general rule for the gradient is, and I'll use this, nope, not that, 3 over 3n plus 1. Nope, 3n plus 3. And of course, that's going to simplify. 1 over 1n plus 1. Alright, hence find the general equation of all lines AQ. Okay, so any line has equation y equals mx plus c. Okay, m is the gradient, which we know. C is the y-intercept. So the general equation is y equals m, we've worked out, which is this. And we now need to write in, can I do that? What the y-intercept is. So if I go back up here, here's AQ. I can see that it's going through P, that's the y-intercept. P is the same in every case, and y-intercept is 2. Right, test your general rule for the gradient. Okay, test using values of n less than or equal to 3. And if you test it correctly, you get 2 marks. So, oh, and you know what the left hand is? Anybody spot it? X. So we take our value of n. Let's say n is equal to 3. We have y is equal to 1. Oops. One over. And so let's change 3 into this formula, so that's 3 plus 1, so that's 4. And then plus 2. So quarter x plus 2. That is the equation of 9. It would be, let's see, -4, -6. Yeah, so it would be this line. That's just what we worked out. I can see that the gradient is 3 over 12. 3 over 12 is the same as 1 over 4. That's your equation for all lines of IQ. Okay, so do the same thing for n equals 1 and n equals 2. I'm not going to do it now. It's the same as the last bit. Prove or verify and justify your general rule and general equation. So in this one, you want to do it for the values that we don't have, okay? So show it is true for n equals 4 or more. Now you also get marks for how you communicate, so make sure your terminology and notation is correct. There's no kind of significant errors. Make sure that you communicate it well. I kind of think if you set it out with these headings that they give you, you can't really go wrong because you just do exactly what they say. Make sure you're using the correct capitalization. You know, if it's a small n, use a small n. Small x, use a small x. Keep it consistent, and you should have no problems. So I went through that pretty quick. If you have any questions, just send me an email, come see me at any time, and we can look at it again in greater detail. Okay? Have a good night.